Figure shows three slits being illuminated by a monochromatic parallel beam of light. Let BP minus AP equal to lambda by 3 and D very much greater than lambda. Find the resultant intensity at point P. This is a screen. This is a screen. And light is incident like this. It is not shown. Look at the three slits we have. Now YDSC we are bringing with three slits. After discussion of this, then you can go for n number of slits you can manage. There's a one slit. Is one slit is there. There's a one slit. The other slit. Slit A, B, C. Small basic mathematics, I think. The mathematics what we had of YDS, you know, the similar mathematics you can bring it here.
I.
3I, yeah?
Yes, sir.
Okay. This data will help you. BP minus AP.
3I, sir.
Yeah, will be 3I. Okay. I need diagram. Let me draw the diagram. Meanwhile, you try. I'll finish off the diagram. Okay, let me proceed here. So I assumed here now. So there's a point A, or slit A, better you call it. This slit A. There's a slit B. I'll come to slit C later on. Slit C is here. Slit C is somewhere here. We'll come to it later on. There's a distance D. and this is the screen. So the distance, this was d, no? So this was the d by 4. This distance will be t by 4. So there's some reference point I took it. This one. So here we'll take like this. So this is the perpendicular. So compared to the light will be incident here. The light will be incident at this point. There's a light.
AB equal to D, sir.
So I'll make arrangement like this. So this is I'll go for again the same method. Like this will be theta. Total angle it is theta. This angle should be theta. No, this will be 90 minus theta. This will be theta. The same in YDSE what we did again, the necessity condition d very much less than d. No, BP minus AP. So let's do one thing. So what all given, like BP minus AP is equal to lambda by 3. This is given for us. Keep it here. There's the equation 1. Let's come for mathematics. Sine theta compared to like a ray A, this one like a ray A, no, and this will be ray B. Compared to ray A, what happened? The ray B will cover more path. What is that path? Delta X AB, you can write it, or XB. I'm taking A as reference. So sine theta, we can write it as sine theta equal to delta XBA by, this will be d by 2. Or delta XBA equal to d by 2 sine theta. Theta very small, so this will be tan theta. From the triangle B, like a PAB. So tan theta.
Sir, length of AB is D, sir.
Length of AB is D. Oh, then I'll make it d by 2. Yeah. This should be d by 2. Yeah, given d by 2. What changes I'll make it? This should be d only, no? It's
Yes.
by d. Delta is BA sine theta. This will be only d will come. D tan theta. Further, tan theta will be d by capital T. So delta XBA. Delta XBA is nothing but what? Like this equation. So let me substitute all the values here. Tan theta value here and delta XBA value here in this equation. So then I'll get this as lambda by 3 is equal to d by d. So therefore d square by d will be lambda by 3. Keep it in hand. It will help us to calculate now the path difference between C and A now. Now similarly we'll go for one more diagram. So same mathematics you can apply to get the path difference between C and A. There, see, we don't know D and that capital D relationship, no? everything should be brought in terms of lambda. From the lambda, I'll get the, so once you know the path difference, then you can calculate the phase difference. Once you know phase difference, then you can go for superposition principle. There's a mathematical treatment is what initially I'm doing it. Now similarly, we'll calculate the path difference between AB already given, lambda by 3. Now with this data, we'll calculate path difference between C and D. The similar geometry is what I'm going to take help of it. Ray will come from C to B. Okay, let's come for this. So the slit C, no, it will be C. This will be B. This will be. So these are the, we are not bothered. B already got over. Now let me take between C and D. No, this distance is what? Capital D. This was given D, and let this be D. So compared to the A, what will happen? The C will cover this much of additional path, call that is N. So this will be the path difference. Delta X CA, you write it. Earlier we wrote delta XBA, no? This will be XCA. So this angle, you call this is alpha. This angle will be alpha. 90 minus alpha. And this will be alpha. Books given some other method, it's left to you, which all I'm very poor in mathematics, so I'm just going for a simple mathematics which is involved. Books that give some alternative method, it's left to you. Any of the method, any of the geometry, you can take help of it. So there's a path difference between that delta XCA, that one. So that has to be calculated. So first I'll proceed like this. In the triangle ANC. In the triangle ANC, sine alpha is equal to delta XAC by D. So delta XAC is equal to D sine alpha. So this will become further D tan alpha. So from the bigger triangle, triangle CAP, from the triangle CAP, tan alpha, we can write it as 2D by capital D. Okay, let me substitute this. So delta XAC is equal to D. This will be 2D by D, or 2D square by capital. So D square by capital D value is what we determined earlier, no? So go back to the earlier value. So that's what the value. D square by capital D was lambda by 3. So this is going to help us a lot. I'll put arrow so that I'm going to substitute here. So delta XAC is equal to 2 by d square by d is lambda by 3, no? Two lambda by 3. Okay, now we got some values. What to do after this? What to do after this? So delta XAB, we got lambda by 3. That's what earlier given, no? The data.
The delta XAC 2D sin alpha, no sir.
2D I'm missing here. Huh? Yeah, D and D, no? Okay. Here 1, 2 will be there. Delta XC is equal to 2D tan alpha is 2D. So this will become 4 altogether. Delta XC will be, this will be 4 lambda by 3. I made correction, just notice all of you. Okay, after getting this, what to do? We have path difference. Can we calculate phase difference? So we'll do one thing. We'll calculate the phase differences. 2 pi lambda into delta XAB. The phase difference between BA and AC, no? I took CA or AC. Okay, no problem anyway. This will be, let me substitute this value. This will be lambda by 3. 2 pi by 3. Means for 5BA, you can write it better. B will lead A, no? So this should be the 5BA. XCA. Symbols, I'll change it. I'll change all symbols. XCA. This should be XCA, XCA, XCA. Because A I'm taking reference, and this will be XBA. XBA it is. Those who have taken those who took screenshot, no, just you. This will be 2 pi by 3. Similarly, we'll calculate phase difference between CA, that one. So this will be 2 pi by lambda into path difference delta XBA. XCA. 2 pi by lambda. XCA is 4 lambda by 3. So 8 pi lambda by 3. So what is the reference? A is the reference. B and C will subtend that much of angle. I think this is something very important. So this data is what now you're going to use. Now how to take help of this data to construct? You go for superposition. What is A? The A will have 0 phase. A will have the waves emitted by the A. By the time they reach P, let it have 0 phase. What about the B? The phase difference. It will have, the B will have a phase of 2 pi by 3 compared to A. What about C? It will have 8 pi by 3. So with this, can you say about B and C, how they will be along the same direction?
Phase.
Almost same phase, no? 2 pi by 3, 8 pi by 3. Now you construct the phasor diagram. Recollect phasor diagram, superposition of SHM, or even in waves and sound. I'll construct the phasor diagram. So this will be the phasor diagram will come like this. This will have 0 degrees, pi by 2. This will be pi. This will be 3 pi by 2. A will have a phase of 0 phase. So what is the amplitude of that? Let it be small a. What about B? B is head of A by how much? 2 pi by 3. 2 pi by 3 means 120 degrees. Similarly, similarly, you compare. So this is of B and this is A. No. Similarly, what will happen? The same thing will work out for this one. 0 degrees. This will be pi by 2, pi, 3 pi by 2. What angle does C again? 8 pi by 3. 8 pi by 3 means again it will also subtend same angle. This is C. Look at now. So shall I add B and C? They are almost like a in phase. So what will be the resultant diagram? The resultant diagram will be A. This will be 2A. And the angle is 120 degrees. So what is the resultant amplitude you have to calculate here? So we have to calculate the resultant intensity. No? So here let I0 be equal to A square. I'll proceed further. Next, this one. What shall I do after this? So now it's about the resultant intensity we have to calculate, no? The angle between, so the resultant intensity will be AR square equal to A square plus 2A whole square plus 2 AB, it is 2A cos of 120 degrees. And what is the intensity? Intensity is proportional to A square. Calculate that, we'll get the resultant intensity. Anybody, how much value? 3 I0?
3 sir.
3
So 3 slits comes, so just be careful. And they didn't, till now they didn't ask. So what you should do is like calculate you take anything reference. So what we did, the scale mathematics, what everyone knows. So proportion of SHM is what I applied here. And intensity is proportional to square of amplitude. So first you calculate the resultant amplitude, then you'll get the resultant intensity. So what is the method when you get any number of slits? Now I think we need to bother. No. So what you should do, you pick up anything. Sir, why you took A only reference? You can take B, you can take C, anything. The one which is simplified mathematics, go for it. So more than 2 slits come, what you should do, take any one slit as reference, then compare to that slit, what is the path difference of the waves coming from other slits. From that path difference, calculate phase difference, then come for the vector addition or the phasor diagram, what we call that one. Then find out the resultant amplitude by considering the amplitude as well as the phase angle. Then square of the resultant amplitude will be the resultant intensity. So this overall method is what we have applied here. I'll scroll it. So those are taking screenshot in laptop, no? Okay, this is about the first initial part of the diagram. D square by capital D we have determined. Completed this, then the next part of the thing. Okay, no, listen. So we'll take the next problem now. One more with the 3 slits on the horizontal 3 slits are there. This completed. Yeah, here we'll paste it.